In this video, I'm going to show you two more pretty challenging exponential problems. So take a look at these problems here. I'm going to solve these in this video, and I hope that through this video you'll be able to understand how to apply the zero and negative exponential rules. So here I see that I have a set of parentheses here and a square, and that means I'm going to square every number and every letter inside of that parentheses. So I'm going to take -4 times -4, which is going to be 16. Now my x has a power of 3, and that's going to multiply by this 2 and make 6. My y has a power already of -2 times 2 is going to be -4. Now over here I'm going to distribute my -1 power, so again I'm just going to multiply my power to the powers that were already there. And when I do that, -1 times -1 is +1. 4 times -1 is -4. Now, I don't have a fraction here, but I can make a fraction by putting it over 1. And any letter or number that has a negative power just means it's on the wrong floor of the fraction. So I'm going to bump these two down to the denominator of the fraction, and then the power will become positive. So those other three pieces here will stay up top, but these two are going to bump down. So y to the 4th, this one, and this one here, y to the 4th. When they bump down, your power will become positive. And now let's kind of put things together. I have a total of 7 x's in the numerator, and in the denominator, a total of 8 y's. Now this one here, I'm going to start by looking at my first initial fraction and just moving anything that has a negative power to the correct floor of the fraction. So I'll start with that. This x squared is going to drop to the denominator. There was an x already there. This y cubed is going to go up, and there was a y squared already on the top. So that's kind of the first fraction we're working towards simplifying. Now I'm going to wait and do this in a second. I'm going to combine this together here next. Y to the 3rd and y squared, add your exponents, you have a total of 5 y's on the top. X squared times 1 more x is a total of 3 x's on the bottom. That's all I can do there. There's nothing I can cancel, so now I'm going to start working on this fraction over here. Everything in your set of parentheses, every number, every letter is going to get assigned that power of -2. If there's a power already there, we just multiply together, so that's going to make -4. And then y to the -2. Now the denominator had xy squared. So all three of these are going to drop down to the denominator, and I want you to know that when you take everything out of the denominator, don't put a 0 there, put a 1. So 4 squared is going to drop down. My x to the -4 is going to drop down. Now right next to it, I'm going to put the x that was already there, because those were alike, so I'm going to put them next to one another. This y squared is going to drop, but there was a y squared already there, so there's that one. So we have now 5 terms in the bottom, the 2 that were already there, and then the 3 that we moved down. So let's simplify this a little bit, and then we'll see if we can do any canceling. All right, 6y to the 5th over x cubed, and times 1 over 16, x to the 4 plus 1 more is 5. 2 plus 2 is 4. Now when we multiply a fraction, we really just have a fraction times a fraction. We really just have one giant fraction. So just kind of think of this as all of these are being multiplied on the top, all of those are being multiplied on the bottom. So I notice that I have a 6 and a 16 that I can do some canceling. These are both even, so I'm going to reduce by 2. So my answer is going to have a 3 over an 8, and that's not going to cancel anymore. Now in the denominator I only have x's, so I'm going to put those together. I have 8 total, because 3 here plus 5 more here. And now if I compare my y's, I have 5 y's on the top, 4 on the bottom. How many more y's are there in the numerator? There's 1 more y, and that is our final answer. Great job hanging in there with these challenging exponential problems.